Imagine flying hundreds of feet above the ground, knowing that the thin metal surrounding you could be the only thing standing between you and a bullet. But helicopter armor isn't simply a thick piece of steel bolted onto an aircraft. It has to be strong enough to stop dangerous threats, yet light enough for the helicopter to actually fly. And behind that balance is a surprisingly sophisticated machining process. Today, we're going inside that process. When people hear the words bulletproof helicopter armor, they might imagine one massive sheet of metal. In reality, aircraft protection is much more complicated. Every kilogram matters. A helicopter already carries engines, fuel, weapons, electronics, crew, and equipment. Adding protection means adding weight, so engineers have to carefully choose where armor is needed and how it will fit into the aircraft. The first challenge is choosing the right material. Armor used in aircraft has to combine several properties that normally work against each other. It needs strength, it needs toughness, it needs resistance to deformation, and perhaps most importantly for an aircraft, it needs to stay as light as possible. This is why aerospace materials can be very different from the ordinary steel you might find in a construction site. Before a piece of armor ever reaches a helicopter, the material can go through inspection and testing. Technicians may check dimensions, surface condition, and material properties to make sure the raw material meets strict requirements. Because if the material is wrong, precision machining won't save it. The goal isn't simply to make something incredibly strong. The goal is to create the best combination of protection, weight, durability, and reliability. Once engineers know what material they're working with, the next step is turning an engineering design into a physical component. This begins digitally. Engineers create a highly precise model that defines the shape, dimensions, mounting points, and other requirements of the component. That digital information can then be prepared for computer-controlled manufacturing. And this is where CNC machines become incredibly important. CNC stands for Computer Numerical Control. Instead of a person manually controlling every movement of the cutting tool, the machine follows carefully prepared digital instructions. The machine can position the part with incredible precision while cutting, drilling, or shaping the material. For aerospace components, that precision matters because even small errors can create problems during assembly. The result is a component that isn't just strong. It is designed to fit exactly where engineers intended it to fit. Now, the real transformation begins. A raw piece of material enters a precision machine and slowly, excess material is removed until the final shape begins to appear. You can actually see the process happening. The cutting tool moves across the surface, producing tiny metal chips as the machine creates the required geometry. Coolant may flow across the cutting area to control heat and help maintain a stable machining process. But machining isn't just about removing metal. It's about creating a component with controlled dimensions and surfaces. After machining, the part can go through inspection. Technicians can use precision measuring equipment to verify that the finished component matches the engineering requirements. This stage is critical because aerospace manufacturing leaves very little room for mistakes. A component can look perfect to the human eye and still require additional measurement before it can be approved. Once the dimensions are verified, the component may receive additional finishing or surface treatment depending on its role. The final goal is a part that can survive demanding conditions while integrating with the aircraft around it. And that is something most people never see when they watch a helicopter flying overhead. What makes helicopter armor fascinating isn't just the armor itself. It's the engineering challenge behind it. Engineers have to think about protection, weight, vibration, temperature, maintenance, aircraft structure, and reliability, all at the same time. Then machinists have to turn those designs into physical components with extraordinary precision. And finally, inspectors have to make sure those components meet the required standards before they become part of an aircraft. It's a chain where every step matters. So the next time you see a helicopter flying through the sky, remember what you're actually looking at. Behind that aircraft is a world of material science, computer modeling, CNC machining, precision measurement, and engineering. The armor may look like a simple piece of metal, but creating it is anything but simple. It is the result of thousands of decisions, precise machines, skilled workers, and engineering designed around one fundamental principle: protecting people without compromising the aircraft. And that's what makes the machining of helicopter armor so fascinating. If you enjoyed going behind the scenes of aerospace engineering, subscribe for more videos showing how the world's most advanced machines are made. Thanks for watching.